You probably feel right now like you are standing at the edge of a moment that hasn't happened yet. You feel like tomorrow is open, like you could go left or go right, like the future is a blank page waiting to be written. That feeling is extraordinarily powerful, and it seems obvious and it seems undeniable. But here's the thing that kept me up at night when I was young and still does sometimes. Physics, real physics, the equations that describe how everything moves and changes, those equations don't have a future tense. They don't know what not yet means. Let me tell you what I mean by that. When Newton sat down and worked out the laws of motion, he discovered something that nobody was quite ready for. If you know where every particle is right now, and you know how fast each one is moving and in which direction, then the mathematics tells you exactly, with no wiggle room, where every single particle will be 1 second from now. And where it was 1 second ago, the equations work equally well in both directions. They are symmetric in time. You can run them forward and you get the future. You can run them backward and you get the past. The math does not care which direction you're going. Now think about what that actually says. If the positions and speeds of every particle in the universe right now completely determine where they will be tomorrow, then what exactly is tomorrow? It isn't open. It isn't being written. It has already been calculated by the structure of reality itself. The state of the universe in 10 years is just as fixed and determined as the state of the universe 10 years ago. The math treats them identically. A French mathematician named Laplace understood this immediately when Newton's work became clear, and he described it in a very direct way. He imagined a mind, a hypothetical calculator, that could know the position and velocity of every single atom in the universe at one instant. He said that for such a mind, nothing would be uncertain. The future, just like the past, would be completely present before its eyes. Now, Laplace didn't have a computer. He was just following the logic of the equations to their natural conclusion. Here's an analogy I like to use. Imagine a very long train on a very straight track. You are standing at one car. You can look forward and see the cars in front of you, and you can look backward and see the cars behind you. All the cars exist. All of them are real right now, at the same moment. The front of the train isn't less real just because you happen to be standing farther back. It's already there. Now imagine that time works like that train. The moment you call yesterday and the moment you call tomorrow are both just cars on the same train. They are both equally real. You happen to be standing at the car called now, but that doesn't make the other cars fictional or unformed. This is the picture that comes out of classical Newtonian mechanics. And it is a picture that Einstein took very seriously and extended in a way that made it much more concrete. Einstein showed us that space and time are not separate things. They are woven together into a single structure called spacetime. And in that structure, every event, your birth, your childhood, what you had for breakfast, what you will do next Tuesday, all of those events exist as points in a four-dimensional geometric object. Physicists call it the blockuniverse, or sometimes the eternalist view. The name doesn't matter. What matters is what it says. It says that all of space-time, past, present, and future exists equally and completely as a fixed geometric structure. The universe isn't a story being told in real time. It is more like a book that has already been written, and you are reading it page by page. Now, the reason Einstein took this seriously is because his theory of relativity makes it almost unavoidable. Here's the key idea. Two observers moving relative to each other will disagree about what is happening right now in distant locations. If I am sitting still and you are moving past me very fast, what you call simultaneous, meaning two events happening at the same moment, is not the same as what I call simultaneous. This is not a matter of confusion or bad instruments. This is a fundamental feature of how space-time geometry works, and here is why that matters for the block universe. If there is no universal now, if my now and your now are genuinely different slices through the same space-time, then neither slice is more real than the other. They are both real. And the events that are future for me but present for you are therefore real events right now, just not from my slice. If future events are real from some valid frame of reference, then they are real, period. The future must already exist as a geometric fact. Einstein wrote in a letter after his good friend Michel Besso died that the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't being sentimental. He was describing what his own equations required. Now let me slow down and make sure I'm being honest with you, because I never like to oversell something. There are real complications here. The first big one is thermodynamics. See, Newton's equations are reversible, but the second law of thermodynamics introduces something called entropy. And entropy creates what physicists call the arrow of time. Entropy is basically a measure of how spread out and disordered the energy in a system is. And the second law says that entropy always increases. Things always go from more ordered to less ordered. You drop a cup of hot tea into cold water and the heat spreads out. It never spontaneously pulls itself back together. An egg breaks but never unbreaks. This asymmetry, this preferred direction of change, is what gives us the feeling that time moves one way and not the other. But notice something crucial. The second law of thermodynamics describes which direction processes tend to go, but it doesn't say the future is undetermined. Even a universe with a clear thermodynamic arrow is still a universe where, given the initial conditions and all the laws, every future state follows necessarily from every past state. The arrow of time explains why we experience time as flowing in one direction. It does not rescue the openness of the future. The future is still fixed. We just travel through it in only one direction. The second complication, and this one is a real puzzle, is quantum mechanics. When you get down to the level of individual particles, things get strange. In quantum mechanics, a particle doesn't have a definite position until you measure it. It exists in what physicists call a superposition, a kind of smeared-out distribution of probabilities. Before you measure an electron, you cannot say it is here or there. You can only say there is a certain probability it will turn up here and a different probability it will turn up there. This introduces genuine randomness into the laws of physics, at least as far as we can tell, and randomness sounds like it breaks determinism. If the future behavior of particles involves irreducible probability, then maybe the future isn't written after all. This is where it gets very interesting and where I want to be careful not to pretend we have everything sorted out, because we don't. The equations of quantum mechanics, before you make a measurement, evolve in a completely deterministic way. The wave function, which is the mathematical object that describes all the probabilities, follows a very precise equation and evolves predictably. The randomness only shows up at the moment of measurement when the wave function appears to collapse to one definite outcome. Why this happens, what it means, whether it is truly random or just looks random from our vantage point, that is called the measurement problem, and it is one of the deepest unsolved questions in physics. Some physicists following the work of Hugh Everett argue that the wave function never actually collapses. Every possible outcome of every measurement happens in branching versions of reality. In that picture, the block universe doesn't just contain one future. It contains all of them, all equally real, all already existing in the full mathematical structure of the quantum state. Determinism returns, but in a much larger and stranger universe. Other physicists think the randomness is genuinely irreducible and that the future is not completely fixed. I want to be honest with you. Nobody knows for certain which of these is right. The math is not in dispute. The interpretation of what the math means is very much in dispute. But here is what I think is the most important point, the thing worth sitting with. Even if quantum mechanics does introduce genuine randomness at the particle level, the large-scale structure of reality, the trajectory of a planet, the expansion of galaxies, the behavior of matter at human scales, all of that is overwhelmingly deterministic. The randomness at the quantum level averages out when you have a huge number of particles. The future of the universe in any sense that matters to you and me is not wide open. The laws constrain it enormously. The space of things that can happen is not the whole space of things you can imagine. It is a very small space determined by what has already happened. And there is something even deeper that comes out of the relativistic picture, something that I find genuinely breathtaking. The reason the block universe feels so strange is that we experience time as flowing. We feel the present moment moving. We feel change, but that feeling of flow, of the present rushing forward, has no place in the equations. The equations describe a static geometric structure. They don't have a variable for now. Physicist Paul Davies has pointed this out very clearly. The concept of the present moment moving through time at a rate of 1 second per second is not a physical thing. It is not in any equation. It is something that arises in our experience, possibly because we are thermodynamic systems with memory, built to process information in the direction of increasing entropy. Think about what that actually suggests. The feeling that the present is special, that now is different from then, Maybe something like the feeling that your location in space is special. If you are standing in Kansas, Kansas feels like the center of the world. The ocean feels far away and less immediate. But the ocean is just as real as Kansas. You just happen to be standing here. Maybe now is the same kind of thing. The moment you are in feels vivid and real and immediate because you happen to be in it. But the moments ahead of you are just as real as the moments behind you. The geometry of space-time doesn't have a special marker that says this is the present, everything past, this is real, everything ahead is not yet. Here is one more thing I want to leave you with. People sometimes hear all of this and they feel uncomfortable, and I understand why. If the future is already determined, if it is sitting there in the geometric structure of space-time waiting for us to arrive at it, then what happens to the feeling of choice, of deciding? I want to be careful here because this is a philosophical question as much as a physical one, and I don't want to pretend physics solves everything it touches. But I will say this. The feeling of deliberating, of weighing options, of choosing, that feeling is itself a physical process. It is what a brain that has not yet received information about the outcome feels like from the inside. A chess computer calculating its next move is going through a computational process. The move that it will eventually make was, in some sense, determined by its circuitry and the position on the board, but the computation still has to happen. The process is real even if the outcome, in principle, follows from prior states. What physics tells us is that the universe is an extraordinarily constrained and mathematical place. The future is not arbitrary. It is not infinitely open. It is tightly wound up in what has already happened, woven into the structure of the same equations that let us predict eclipses centuries in advance and calculate the orbit of a spacecraft that has been traveling for 50 years. That predictability, that lawfulness, that is not a limitation on the universe. It is the most profound thing about it. The fact that the future is connected to the past by tight, beautiful mathematical laws is exactly what makes science possible and what makes the universe so extraordinary to think about. The future may already exist somewhere in the geometry of space-time, but we still have to live forward through it, experiencing each moment as it comes, and perhaps that is the most interesting thing of all.